Welcome back, my friends. In today's video, I'm showing you everything you need to know about using GitHub Actions. I can't tell you how often I've heard that GitHub Actions is so powerful, but whenever I tried looking into it, it felt kind of complicated to me. But at some point I realized that actually it isn't that hard, it's just a bunch of YAML instructions chained together. So today, in order to teach you how all of that works, we're going to build out a very simple example from scratch and then automate everything with GitHub Actions. First, we're going to build an ugly README file that just displays the time and date. Second, we're going to push this to GitHub. And then third, we are going to automate this process of re-rendering this file. And then in the fourth and last step, we are even going to take this ugly README file and publish it to a website using Netlify. Now, I know this doesn't feel like a super sexy example, but it actually teaches you everything you need to know about GitHub Actions. So let's head into our studio and start building things from scratch. Alright, here I set up a new RStudio project that's completely clean. Basically what I've done is I've created a new project and clicked on new directory, set new project, and then I put in a name. In this case it's GitHub Actions Test 2. And then I made sure that I create a Git repository for this, and I also used the rnv package with this project to make sure that all of my packages are version controlled. So basically that's what I've done. I'm not clicking create project here because I've already done this. And then I've created a Quarto file that's called readme.qmd. Basically, I do want to just fill this file with something that generates a timestamp for me, which I can then push to GitHub so that I can always see that the code was run and the timestamp updated. Really, this is a super simple project, but it teaches you so much of how to work with GitHub Actions. So let's fill this Quarto file with a little bit of text. Let's insert a headline. Let's just set GitHub Actions test, and then we run a calculation. In this case, we just want to get the time, and then we want to use the format command to put this into a nice timestamp. So let's just use this format here so that we have a nice output like this, and let's save this in a variable called current time. And then I'll just throw in a text that says, hello, this file was rendered at, and then I'll throw in an R code chunk that just uses this current time variable as an output. So now if I render this, we'll see that I do get error messages because it says there is no package called R Markdown. You can even see the warning up here. And the reason for that is because I've used rnv in here, which means that I start with no package installed. So this is why I can just use this install packages command. But in this case, I do use the rnv install so that it's immediately documented in my log file. So I'm downloading and installing these files, and I have to do the same thing with R Markdown and installing that as well. And we see that everything was successfully installed, and then we can say rnv snapshot to document everything in my log file. I thought this was done automatically when we run install, but I guess not. So let's just document everything in my log file. And in case you haven't seen this before with rnv, this will just generate a file that documents your R version and all of the packages and the versions of the packages. That's a great feature for reproducibility so that you can always be sure that your code runs with the same packages, and this will help to make sure that your code still works when you try to run it in 3 or 4 years. So back in my Quarto file, we can now render this, or at least we can try, and we see that this actually worked. Now I don't want to have the code chunk be displayed, so I'll just throw in the echo is false option, and now the code chunk isn't displayed anymore. Right now, if we look into the files pane, we'll see that this generated an HTML file, which is not the typical README format that GitHub accepts. So we have to make sure that the output is not HTML, but we have to make sure that it's GitHub flavored Markdown. So in the format YAML header, we use GFM as in GitHub flavored Markdown. And now if we execute this, we see that the output looks slightly different, but more importantly, we see now that we have this Markdown file rendered here. So once again, it's a really simple output, but we do want to automate this thing using GitHub Actions now to understand or to learn how GitHub Actions works. One thing we have to learn for that is to understand how to render a Quarto document. Previously, I've just always pressed Ctrl-Shift-K, which is the shortcut for rendering, or you could also press the render render button, but you also need to understand what happens behind the scenes to make that work. And really what happens behind the scenes is that in your terminal, the quarto render command is executed. So if I use quarto, then use the render command, some room here, and then specify the file that I want to render, then I'll see that, okay, now this thing is rendered and we see here that the output file was readme.md. Okay, so this is really what quarto does. When you hit the render button, it just executes behind the scenes this quarto render command on your file, and it uses the specifications from your YAML header to make sure that it knows the stuff like the out format and so on. So now that we have created a very basic project, it's time to get this online to GitHub. So the first thing is to check what our local repository does, and right now there are no commits at all yet. So let's just add everything and then commit everything using the message everything setup. Then you'll see that everything was added to it. So there's nothing to commit anymore. So now we can try to push this to the repository, but we haven't set up a GitHub repository yet. Right now it's only a local Git repository on my computer. So let us head to GitHub to create a new repository. Here I'll just call this GitHub Actions Test 2, just like my project. I'll put in a description that tells me that this was the video demo, and then I'll make this a public repository. I will not add a README file because I don't want to have this pre-filled. I want to use my own, and I also won't use any git ignore or any license. So I'll just create a clean repository. And here it says, okay, this repository is now available, but it isn't empty. We need to make sure that we can push to it. So now back in RStudio, we see that, okay, to make git push work, it tells us you have to specify something like this. And GitHub is kind enough that it tells us, yeah, this is the command you're looking for. So let's just take all of this and throw this into our console. So now you see that we have pushed the changes here. And if we use git status, it tells us that we are on branch main. The name was changed from master to main. And we also know that we're now tracking with the remote repository on GitHub. So now if I refresh my page, we should see that, yep, here is my repository filled with the file I had on my computer. And here is the README file. So that's cool. I could now re-render my Quarto document and then push everything to see this update here. Let me just show you. Let's just re-render this. Then we see it's 4 minutes later now. And then we just add this readme.md file, and then we commit it. Let's just call this update, and then we push this. And now if we update our website, if I refresh this, you should see that this one here should be at a later time now. And indeed it is. So basically this was just a refresher on how to use Git and GitHub in tandem. Now comes the fun part. Now it's time to automate this whole process, that whenever I push to this or on a particular schedule, this whole workflow is re-executed. So this Quarto file is re-rendered and this markdown file is also re-rendered. For that, we could go to actions and then start for something and try to configure something. We could go with set up a workflow yourself, but here I want to show you what happens behind the scenes so that you're not dependent on clicking your way through this interface here. Instead, what we could do is to just create a hidden GitHub directory where we can specify workflows. So let's create a new folder. Let's call it .github. We call it like that so that GitHub knows when we push this stuff into our repository on GitHub that it knows to look in there to find stuff. Now all the workflows with GitHub Actions, they lie in a new directory called workflows. So let's create that as well. And in here we can now create a new text file. Let's call it main. And then we want to make sure that it's a YAML file. So we call it main.yaml. And now to specify a workflow, we have to fill this YAML file, which is just a file that has a very specific format, which I'll show you in a second in case you haven't seen it before. So the first thing we need to specify is the name of our workflow. Let's call it re-rendering the readme file. That's the name. Let's just go with that. So in YAML, you just have to specify the attribute followed by the value of that attribute. Just like we have with the YAML header in Quarto, we can do the exact same thing in our main YAML file to create a workflow. Next, we want to specify when this workflow should start, when it should run. And for that, there's the on attribute. And here we want to make sure that it renders on push. We could also do on schedule and then throw in options in here, or for the push, we can throw in options in here. But right now I do want to focus only on the push. So whenever we push to our repository, we want to date things. And for that, we want to track specific branches. So let's just go with branches, and then we could list all the branches that we want to track. In this case, we want to track the main branch. We could also list more branches with other names, but here I only have the main branch, so let's just go with this. All right, so far so good. It's nothing really scary, you just have to get used to this format. But I think you see that if you go through it step by step, you can actually understand what is supposed to happen. Now let's fill our job with actual things to do. For that, we have to specify jobs that need to be executed. So in one action, we can run multiple jobs, but here that isn't really necessary. So we'll just specify the one that we want to have, and we call this render. Let's just call this job render. We could also call it render my file. And if we wanted to also include some other job in here, we could also say, I don't know, name this other job. The point is that you have to nest specifications of what to do in these jobs in the next layer of your YAML file. But as I've said, we only want to have one job, so we'll just go with this one here. Let's just call it render my file. Doesn't matter what it's called, let's just go with this name. Now this job needs a few things. First, every job needs to run on a machine. We have done everything manually so far on our computer, so this means that it ran on our computer, or basically my computer. But when you want GitHub to do the same thing, it also needs a computer. So we need to tell it on what kind of machine it needs to run things. We don't have to worry about how GitHub does that. We just tell it, you know what, run the job on a specific machine that uses, for example, Ubuntu in the latest version. That's a typical thing to do, which you'll see all the time. So we'll just go with this one here. And just to stress the point, this part here is really not dependent on what you use on your computer. Again, GitHub in the background will provision a machine that uses Ubuntu, but we don't have to worry about how GitHub does that. Next, we'll need a few permissions. So let's use the permissions argument. And in there, we'll need the permission to write contents. This is due to the fact that, of course, we will update the files in our repository. I mean, we want to re-render the README file, so we need to make sure that we can overwrite stuff. And this is how we make sure that inside of this particular job, we can actually write stuff. So as you can see, there's a lot of overhead stuff that you need to define first before you can even begin to define the steps that the action is supposed to take. But now that it's done, we can finally specify the steps that the particular job render my file will take one after the other. And one job is always defined by a name and by the things that it's supposed to do. Often that's uses, because we can then say use some specific action that is predefined, or we could also use run to run a particular command, just like we've done earlier when we called quarto render. When we did this here, this is something we could then tell it at the end when we have executed everything else to say run this quarto render command. But we'll get there. For now, let's just use the uses attribute here. Now the first step is always the checkout repository. This will tell the machine that GitHub uses to run these jobs to check out the repository to get all of the files that we need. So that's why we call this step checkout repository, and we don't even have to think about how to do this kind of thing. There are predefined actions that we can just specify using the users attribute. In this case, the action we want to take is the checkout action in the latest version. You can just Google what the latest version is, or you could also look for other predefined actions that you could use just to get a sense of what is available. Then our next step is to make sure that Quarto even works. I mean, we want to, at the end, our goal is to execute Quarto render readme. But at some point, in order to make this work, I had to install Quarto on my computer. But this machine that GitHub uses will not have Quarto pre-installed out of the box. So that's why we need to make sure that one of the first steps is to actually install Quarto. So let's call this install Quarto CLI. And the nice thing is that we don't even have to think about how to do this on this remote machine. With Quarto, as is probably true with all kinds of other cool tools that are out there are predefined actions as well. In this case, the action comes from another GitHub repository. Namely, if you check out the Quarto page on GitHub, you'll see that it has a Quarto actions repository. If you check that out and look into README, you'll see that there are a couple of actions that you could use. And one of those is the install Quarto action. So here, all you have to do is to take this action here and throw this into the users attribute again. And then if you look into this page here, it says we recommend using v2. All right, just like we've done here, we can specify a specific version. So let's just go with v2. If you're curious what this does, you can just check out this link and it will lead you to the directory inside of that repository where you have all of the things described, and it will even tell you how to use this thing. And sometimes it will also tell you what kind of inputs are available. For example, you could specify that you want to use a specific version of Quarto. So let's try this. Let's just take this part here and throw this in here. But here we might not want to use the specific version. We could also, just like with Ubuntu, we could say use the latest version. And in case you're ever curious what a particular action does, you could just look into the action.yaml file. And there you notice that it's an exact same YAML file that we're currently specifying, only that it's much more complicated because they use way more fancy stuff and they have a lot of if statements in there because depending on the inputs, you might have to do something else. So that's something you could use to satisfy your curiosity, but in general, you don't ever have to look into it. You can just use the information that they specify here on that particular page. So with that, we have installed Quarto, which is nice because it also comes pre-bundled with R, so we don't have to install it on our computer, or rather on GitHub's computer that it's currently using to run our code. So we don't have to install R, but we do have to make sure that it uses the package we have specified. And if you recall, the random log file is the way to tell R what packages and what versions to use. So that's why we create a new step. Let's call it install R packages. And for that, we'll use the runs command. Whenever you have something like this, so whenever you use runs, it's typical to start with a vertical line because this tells this YAML format that we continue on the next line, and then you can do all of your coding on separate lines. And that's just a formatting thing that you might want to do. So on an Ubuntu machine, you could call R using the R script command, and you could run a particular command using the E flag, and then you'd specify the command that it should run. In this case, it should install a package, and the package in this case is the rnv package, because in order to restore the things from the rnv log file, we first need to install rnv. So you can see with these steps, once again, even when you start defining the steps, there's overhead work to do. Namely, you first have to set up your machine, just like you have at some point set up your computer to be able to execute R code or to restore packages from an rnv log file. And then once that is done, we can execute another command using the same strategy, but this time we use rnv, and there we use the restore command. Now this will technically work, but one thing you have to keep in mind is that all of these steps will be re-executed whenever this action runs. So in our case, whenever we push something to our main branch, we'll see that all of the steps need to be taken care of. And installing packages can take really long, but there's one trick to speed up things, and this is not to install from CRAN using so-called source files, but instead using binary files from the POSIT package manager. The only thing you have to do to make that happen is to specify the repository that you want to install from. So in the install packages command, you could set the repos command to the package manager from POSIT, and you can do the same thing in the rnv restore command. This is just a little tidbit for you so that you can speed up your actions workflow, because that way the installation will be much quicker. And now that we have set up all of the things, we can finally include the step that we really want to do, is to re-render the Quarto file. And in this case, what we have to do is to run the Quarto render command just like we've done before. So it is the command just like we had earlier. And then you'd think you're done, but you're forgetting that you still have to commit to the changes. Otherwise, they won't be available in our GitHub repository on the front page. So our last step is to commit the stuff. So commit the readme.md file. And for that, we just need to run a couple of command line commands to do this git stuff you have seen me do earlier. So this would be to git add this new file, and then to commit it into the repository, and then to push it. But there's one thing that you once again have to think about, namely who does this pushing, who uses this git command. At some point in your life, you have set GitHub to have your name and email address associated with it. But on this machine that GitHub uses, this isn't the case yet. So we have to tell it, you know what, use the following name and email email. And with GitHub Actions, there's a default way to do that. You don't even have to think about it. You just use the git config global username. This is the thing you at some point ran when you installed Git on your computer. And then you use GitHub Actions bot and you use the associated email with that. Now, in order for this last thing to work, we need to make sure that we can actually push to the repository. And typically this stuff is handled by a GitHub token. You might remember having to set up this at some point. Thankfully, every GitHub repository already has such a token set up, but you have to make sure that the user that uses these commands here can actually access that secret. So that's why you have to specify that the environment in which to run this last step uses the following environment variable called GitHub token. This is the one we need. And this one will be retrieved using this bracket notation from the secret store that every GitHub repository has. And in there, by default, there is a secret called GitHub token that has the actual value that we want. Whew, that was a lot, but we should be done now. So we can now save this file and then push this to our repository. But let's git add everything, then git commit everything. Let's call it setup workflow. And then we push this. And now if we look into our repository, we see that we have this new workflows directory here, and then there is our YAML file. So we successfully pushed this. And if we look into the actions, we see that there is one workflow run, but as is typical, it failed. And this will be something you have to get used to at first. Setting things up with this workflow is always a little bit of a trial and error thing. So let's check out what happened here. So here there was an error because we must have forgot that a step needs to have a uses or a run command. So let's check out what we have here. And that's a bit dumb. We always wrote runs instead of run. So let's just get rid of the extra S's here. Then we save everything. Then we have to push. First we have to commit and then we push. By the way, it doesn't matter if you use the command line to do this adding, committing and pushing. I just like to do it, but you're perfectly fine to use the GUI that RStudio gives you. In any case, let's just check if our action now works, and it seems to at least start. So let's check out what happens here. You can see here that my job called render my file is currently running. It's been running for 15 seconds. And here you see now all of the steps that are currently running. So right now it is installing the packages. But if we are not interested in seeing that, we could also check out what happened before. As you can see, all of the things that we specified by name in the YAML file can be seen here. And you see that Porto was basically downloaded in this case. That's basically the download logs. And then at some point it's installed. Let's just minimize this here. And then let's check out if all the other things went through. And it seems that this worked fine. All of the steps have a check mark on it. And if we look into the action, it's actually green. And now we can see that this time must have been updated. Interestingly, it's 11:03, even though my time is 12:03, or it must have been 12:03. We of course also need to account for time zones, but for now let's just ignore this. Just be aware that the time zone of the machine that GitHub uses to run your code might be different, so you'd have to really hard code the time zone it's supposed to use. Here, let's just ignore this for now. Instead, what I want to show you is how to deal with secrets. You know, you probably still remember that we had to use this GitHub token thing to actually make the commits work. And that's a typical thing to do, that you have to use some secrets like a GitHub token to get a job done. And to show you what I mean, let me take this example of updating the README file or this rerunning this code here. Let me take that one step further. For example, I might want to publish my files on Netlify. For that, Quarto has a pre-built option that's called Quarto Publish. And if you execute this, it will ask you, well, what do you want to publish? So we also have to specify that we want to publish the README QMD file. And then it asks me, where do we want to publish? In this case, we want to publish on Netlify. Then it will say, do you want to authorize this? I will say, yeah, sure. And then my Netlify will open and I can authorize this application. And now if we look at this, we see that we got an error because we're currently specifying that the output is only supposed to be GitHub flavored Markdown, but for Netlify, we also need HTML. So for that, we can specify that we want to have two separate outputs, namely GitHub flavored Markdown and HTML. So if we try to re-render this, we'll see that it doesn't work, but that's totally on me. We actually have to stick to this format here. Let's just throw this in there, and then we say here, use GitHub flavored markdown. And now if we re-render this, this should work. And indeed it does. And we can even switch between the different formats here if we wanted to. So with that, we can try to re-execute our publishing command here. And now it will ask us once again, yep, Netlify, authorize this. And we have to once again accept that. And now we see that everything is rendered and everything is pushed to Netlify. And you see here now that my beautiful readme.qmd file was published to Netlify. So back in our studio, we could try to automate this thing so that our YAML file has another step in here that says something like publish to Netlify. So let's call this publish to Netlify, and then we'll have to run the same command we just ran, namely quarto render and readme.qmd. And actually it's not render, it is publish. But now if you think about it, this cannot possibly work because we have seen when we ran the command, we were prompted to authorize this application by Netlify. But still, it's instructive to see what goes wrong if we just try to make this work. So let's just git add everything, and then let's git commit this with the message that says enable Netlify. So now if we push this, then we see we cannot push because we first have to pull, of course, because our file was modified due to the GitHub action. So that's why we have to pull first. Since this is a new repository, it asks us, what shall I do? Let's just go with the default strategy and throw this in here. And now we can actually pull. And of course, there are merge conflicts, which is just natural because we have changed stuff. So let's just take the latest version of this, save it, and then we have to commit everything, and then we can finally push. And now that this worked, we can check on our repository again, and we should see that some action is running. So here we can check this out, and it seems like it's re-rendering my file currently. And a really dumb thing happened. The last step isn't in there because I forgot to actually save this change to the YAML file. So just changing that, committing it, and pushing it again should also start a new job. This one will probably fail because it will run into merge conflicts, but it doesn't matter. We now see that our new job has this publish to Netlify step. So right now it tells us that everything worked. If we look at this, it looks like this publish to Netlify worked, at least it finished. But if we refresh our page, then we'll see that this actually remained unchanged. So this didn't actually do what we wanted to do. And if we look into our code, we see that the correct time should be 11:16. So this really shows us that even though the step ran through, it didn't actually accomplish what we want. And that is really because this authorization step was missing. Thankfully, the Quarto Actions repository also has another action for us that is called publish. So we could look at that. And then it tells us how we can publish on Netlify. It tells us that we need a Netlify auth token. And then we could use the publish action that Quarto gives us. But really, I don't want to do that here. Instead, I just want to take the information that it tells me I need this Netlify auth token from a secret. So let's just generate that. For that, we just have to follow the steps here to generate a Netlify token. So we'll just go to the applications page and then create a new access token. Here I'll just call this GitHub demo, and then I'll generate a token. So here let's just take this token here, and then we have to, inside of our repository where the action run, we have to go to the settings and then have to go to secrets where we can define secrets for actions. And here we can add a new repository secret, which we fill using the token we've just got. And then we call this secret Netlify auth token just as was specified. So let's just add the secret. And now back in our YAML file, we have to tell this step that it can actually use this secret. So just like with the GitHub token, we throw in another step. Let's call it env. And then we call Netlify auth token. And then we get something from the secret store. So from the repository secrets. And there, this is the name that we have used inside of GitHub. Since we've also called it Netlify auth token there, we just have to use the same name here again. And now we can add and commit everything. So let's git pull all the changes from the GitHub actions, and then let's git add everything and commit with the message that we added the Netlify auth token, and then we can push to the stuff. And now on our actions page, we can see that this commit triggered another run. So there we can see now that this is still running. And now it finished. And if we look into the steps, we can actually look into the publish to Netlify step. And we see now that there is actually more output for this quoto publish command. And if we scroll all the way down, it looks like it was published. And if we now refresh our page, we see that the time was updated. Nice, that worked. Now let me show you one more cool thing before I let you go off do something else. Back in our YAML file, we could additionally to the push thing also define a schedule. So let's define a schedule that will tell us to run this job regularly and not just whenever I push to it, because pushing still requires manual intervention, but on a schedule, I can just tell GitHub Actions to run this thing every 15 minutes or something. The lowest number that you can go is 5 minutes on GitHub, I believe, but for most use cases, I believe that should be fine. I have a way you can create a schedule using a cron job. If you've never worked with it before, cron is this cool tool that allows you to automate stuff on a schedule. And it has a particular notation to describe when we want to run things. So basically, the job frequency is defined by a string, and the string is defined by 5 asterisks. And before I try to give you a long-winded explanation, here take one of the many images out there in the internet that explain how to read this 5 asterisk notation. Basically, the leftmost asterisk describes on what minute you want to run something. So if you always want to run your job at the 5th minute of every hour, just write a 5 in the first asterisk and leave all the asterisks as is. So this notation here would mean that we'd run this at 105, 205, 305, and so on, because all the other specifications are just larger units. So this second asterisk describes on what hour you want to run. Since we left it as an asterisk, we mean all. The third asterisk is what day of the month, can be a number between 1 and 31. Then the next asterisk is the month of the year, and the next asterisk is the day of the week. So with this command, we'd run it at 105, 205, and so on. But if you wanted to, for example, run this command at specifically 205 for every day, then you just specify a 2 here. So that's the cron notation. But if you want to specify a frequency, what you could do is to just use the asterisk and then say divide by 5. So it will use every minute that is divisible by 5. In this case, I do want to use a 10-minute frequency schedule. And that way, this here describes that we want to rerun the whole thing every 10 minutes. So all that's left to do is to add and push that, which you cannot do because you have to pull first. But then after you've pushed, you will see that this job runs one more time because we pushed again. But after that, it will run every 10 minutes. So with that, we have successfully learned how to use GitHub Actions to run anything we want. We can now use any package we want by making sure that all the packages are documented in the log file. And then we can run any code that we want by either executing an R script or throwing this into a quoto file that gets rendered. And the other steps of this workflow can just remain the exact same way for every job that you have. So you now have a basic skeleton on how to operate GitHub Actions. I hope this demystified GitHub Actions a little bit for you. Feel free to let me know in the comments if that was the case. And if you enjoyed this video, then I'm sure that you're also going to enjoy my data cleaning masterclass, where I show you how to get faster and better at data cleaning so that you can focus on the things that matter to you more. Or if you want to check out one of my other videos, you can also stroll through this playlist right here. And now all that's left to say is thank you for watching, and I will see you next time.